Now we're going to be solving absolute value equations. So what is absolute value? Absolute value of a number is the distance it is away from 0. So if we have 0 here on my number line, if something has the absolute value of 5, then that something inside the absolute value bars is 5 away from 0. So if I'm at 0 and I go up 5, 1, 2, 3, 4, 5, that means the something inside the absolute value bars could be 5. But remember, we can go the opposite way towards the negative numbers, 1, 2, 3, 4, 5. And that something inside the absolute value bars could also be negative 5. Absolute value equations have variables within the absolute value signs. So here's one example, the absolute value of x equals 7. So whenever we take the absolute value of x, we get positive 7. Now there's multiple possibilities of what x could be. We could have positive 7, so the absolute value of positive 7 is 7. Or we could have taken the absolute value of negative 7, which still the absolute value is positive 7. So here x could be 7, or x could be negative 7. Now remember, the absolute value is always positive. It can never be negative. So once the absolute value bars are isolated, what's on the opposite side of the equal sign must be positive. Alright, so this equation has a little bit more going on. We have the absolute value of 2x minus 1 equals 5. So remember, that means that whatever's inside the absolute value has to equal 5, or whatever's in the absolute value has to equal negative 5. So in order to solve this, we're going to set up two mini equations. Now it's important to remember that I cannot get out of these absolute value bars unless I write these two mini equations. So I'm going to have 2x minus 1 is going to be 5, or 2x minus 1 is negative 5. Now I can solve these just like a normal equation. Now, of course, just like any equation, once you have x solved for, you want to go ahead and plug it in to check your work. So x equals 3, let's plug that in. 2 times 3 is 6. 6 minus 1 is 5. The absolute value of 5 is 5. So this one is going to work. Now let's check negative 2. So 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is positive 5. So again, this one will work as well. If I want to graph these, well, now on a number line, I'm going to have a closed dot at negative 2 as well as a closed dot at 3. And there are my solutions. Alright, now here I have 3 times the absolute value of x plus 2 minus 1 equals 8. So obviously this looks different. So we have to stop and think about how this is different than the last example. Well, the last example didn't have anything multiplied in front of the absolute value and didn't have anything subtracting. So I need to isolate the absolute value bars before I can break it into my two mini equations. That's the most important thing. Isolate the absolute value. So I'm going to go ahead and rewrite my equation here. So I need to get these absolute value bars completely isolated. So the first thing we do is we're going to add the 1 to each side. You always do your addition or subtraction before you start thinking about this multiplied constant in front. And now I'm going to divide each side by 3 to get rid of that multiplied 3 out front. So remember, dividing whenever something is multiplied is its inverse operation. So now I have the absolute value of x plus 2 equals 3. So now the absolute value bars are completely isolated. So I have something inside equaling 3. So that something equals 3, or that something equals negative 3. So go ahead and solve. X is going to be 1, or x is going to be negative 5. And of course, you would go ahead and check those solutions. And we're going to graph them on a number line. So x is 1, or x is negative 5. And there are my solutions. We previously spoke about how distance cannot be negative. Therefore, sometimes you'll get absolute value equations such as this, absolute value of x equals -5, that have no solution at all because absolute value, which remember is the distance from 0, cannot be negative. So it's important to make sure that you always check your solutions once you've solved, because sometimes one or more of those solutions can be extraneous. Extraneous solutions are solutions that derive from the original equation but are not solutions of that original equation. So make sure that you check your answers. Now, if both of the x values that you find do not work, then the solution is no solution. So if there are no x values that will make that equation true, the answer is no solution. So this looks a little different than the last equation that we looked at as well, because I have x's on the inside and the outside. So remember, absolute value of something equals 4x plus 5. So the stuff on the inside could equal 4x plus 5, or the stuff on the inside could equal negative 4x plus 5. And if you distribute that negative sign, you get negative 4x minus 5. So it's super important to put these parentheses there, or else you would have missed the negative on the back 5, and the negative has to go to both. So whenever you rewrite it, you just change the sign of both terms. So now rewriting my equation here. My absolute value is already isolated, so I don't have to do any additional work. So in order to break out of the absolute value bars, I have 3x plus 2 equals positive 4x plus 5, or 3x plus 2 equals negative 4x minus 5. And remember, we did that right up here. So remember, you change the sign of both of the terms. So if it was initially negative, then you make it positive. So now we just solve each equation. So after solving the equations, we get x equals -3 or x equals -1. Now we must check for extraneous solutions. So let's go ahead and check -3. Checking -3, I get 3 times -3 plus 2. We want to know, does that equal 4 times -3 plus 5? Well, already I see some issues, and the issues are on the right-hand side, I'm going to end up getting -12 plus 5, which is -7. Now on the left-hand side, I have absolute value bars. It doesn't really matter what's happening inside these absolute value bars. You could go ahead and simplify it. We get -9 plus 2, then we get -7. But the absolute value of -7 does not equal -7. The absolute value equals +7. We can never have an absolute value equal to a negative number. So this guy is not going to work. These are not equal. So -3 is not a solution. So now let's try the absolute value of 3 times -1 plus 2. We want to know, does that equal 4 times -1 plus 5? So simplifying what's in the absolute value bars, -3 plus 2 is -1. 4 times -1 is -4, plus 5 is +1. So does the absolute value of -1 equal 1? Well, yes, it does. Therefore, x equals 1 is my only solution, because x equals -3 did not work. Now, if x equals -1 ended up not working as well, my solution would have just been no solution. Alright, so give these a try and make sure that you check your work, and for number 1 and 2, graph your solutions.